So welcome back to the second part of our Immutable Infrastructure series. Last time we looked at Terraform. We had a quick overview of what it can do and why it kind of works and the way it does. And one of the things that I mentioned was about the importance of codified and immutable infrastructure. And to kind of take that to the full extent, we don't just need to be able to use Terraform for provisioning our infrastructure, but we also need to be able to use a way of managing images. So today I want to quickly look at a tool called PACA. And PACA complements Terraform in many ways, and we'll see just how easy it is to be able to create PACA images inside of DigitalOcean. So what is PACA? So PACA is a tool which allows you to manage infrastructure as code for your images. And if you remember back from last time, we talked about some of the benefits of infrastructure as code, and we said that infrastructure as code increases productivity and transparency because it allows you to share your code amongst your team and to store it inside of things like version control, which enables easy sort of collaboration. And one of the other things that we said was that if it can be codified, it can be automated. So PACA takes that and it kind of follows on from Terraform, but looks specifically at application images and application software. So PACA configuration, you're not going to be building things out in HCL like Terraform. What you do is use JSON. But the PACA configuration is fairly straightforward. These are kind of some of the key elements. We've got variables, builders, and provisioners. And we're going to take a deeper look into this. So I'm not going to discuss too much about it right now. But it's an open source tool, and the purpose of it is to create identical machine images for multiple platforms from a single source. And if you remember back from the previous video, one of the things that we talked about when we said why immutable, well, the concept around why immutable is to be able to have consistency and reproducibility. I always want to be able to recreate my infrastructure or my application in exactly the same way every time I run it. With Terraform, of course, I can do that on an infrastructure layer, but if I'm going to be doing things like provisioning software on droplets, every time I spin up my infrastructure, I'm not going to get that consistency. Packages can change between runs. You can have issues where, it just doesn't work for whatever reason. And the rationale behind using a gold master image is that it's always going to be the same. It's always going to be consistent because I'm not provisioning that application software every time I try to create my infrastructure. I'm doing it ahead of time. I create those images, then I provision them. So every time I provision a new environment, I'm going to have exactly the same image. So I'm going to have exactly the same base level software, exactly the same operating system, application configuration, all of those things. And those are the things which really help to contribute to being able to have that consistent and reproducible approach. PACA works with all major operating systems. It's not just a tool for Linux, but you can use it across all infrastructure providers. Now, one thing is that it doesn't replace Ansible, Chef, or Puppet. So PACA is really just a tool for kind of wrapping all of that up. So PACA will provision an image, and then it will execute the likes of your Ansible playbooks or Chef cookbooks. And then that's the step that installs all of your application. PACA then goes ahead and it will take a snapshot of that image and store it for later use. Simple command. So the predominant command that you're going to use is PACA build. So I'm just running PACA build here, and it runs through a number of steps. So the first thing it's going to do is it's going to create an SSH key for a droplet. Then it's going to create the droplet. And then once it's able to SSH into that droplet, in this instance, I'm using an Ansible Playbook. So it's going to execute my Ansible Playbook. And once all of that is complete, it's going to save that snapshot, and you can see there that it's going to create that with a name and an ID. So let's take a quick look at how this works. So I'm going to start with a blank JSON file. And the first thing I want to add are my builders. So the builders is an array, and it allows me to specify multiple cloud providers to which I want to build this particular image. So I'm just using DigitalOcean. I've only got a single one specified in here, but I could have multiple. So I could choose to be building it into multiple regions if I wanted inside of DigitalOcean. And I'm also using an image. So inside of the image, kind of not really like Terraform's interpolation syntax, but you do have the ability to make your configuration dynamic. So I'm using a variable here called image. So if I add that variable, you can see that I've got an image here, and I'm just referencing Ubuntu 16.04. So this is going to be my base image that I'm going to use in order to build my new image. And I'm specifying things like the region and size and the username, which is just going to be root. And this is just for the SSH configuration. So the snapshot name is what I'm going to save my snapshot to be. So in this instance, I'm going to call it example. I'm again referencing that variable, so that image variable. So it's going to be example Ubuntu 16.04x64. And then I'm going to specify a version. So again, I've got another variable called version. So once we've done that, what we want to do is we want to prepare ourselves some Ansible. So let's create an Ansible Playbook. So in the header of my Ansible Playbook, what I'm going to do is I'm just going to call this install server. I'm using hosts all, gather facts false, which is quite important if the base image doesn't have a Python already installed on it, and the remote user. Then what I can do is add some pre-tasks. So what I need to do in order to be able to run my Ansible Playbook on my new DigitalOcean droplet is install Python 2. So this gather facts, if I'd had this set to true, this would have failed because it has a dependency on Python, which isn't installed by default. So I'm just checking to see if that's installed, and if not, I'm going to go ahead and install it. Then I can go ahead and do Ansible's gather fact stage. So let's add some tasks. So I'm not going to do anything sophisticated inside of this playbook, but I'm just going to update apt. I'm going to install the package HTTP transport for apt, CA certificates, curl, and the software properties. So I'm going to install nginx. And this is all my task is really doing. But you can see here that I'm actually capable of using a variable. So I'm going to use my variable version, which I've got defined in my PACA configuration. And all I'm doing really is just copying a file, which is a simple HTML file, which I've got set up over here. And I'm just copying that into a folder. But again, it's just using a dynamic variable. So let's go back over to our Ansible configuration. And what we want to do is add our provisioners block. So our provisioners block is going to run the Ansible playbook. So we got our variables. This is where we're setting up our initial conditions. We've got our builders. These are the things which are going to go ahead and create the image and run the process for us. And the provisioners. So I'm using Ansible. I have a playbook file, and that's just that playbook that I just created, just a simple one to install nginx and copy over a file. And I'm adding these extra arguments. So if you remember back, I'm referencing this variable here, version. So what I can do inside of my playbook is I can use these extra vars, and I can specify version, which is going to be my PACA version, which I've got defined up there on line 4. And that's all I need to do to set that up. So let's go ahead and provision that image. Okay, so what I'm going to do is I'm going to run PACA build. So PACA build, and then my configuration file, example.json. So what's going to happen now is that PACA is going to create a droplet inside of DigitalOcean. So let me just refresh my droplets. And you can see there it is. So it's going to spin that up, and then it's going to provision it with some temporary SSH credentials. Once that's complete and available, then PACA is going to start installing my Ansible Playbook using an SSH connection. So that generally takes about 25 seconds or so. And there we nearly go, but let's go back over here. So PACA is now connected up to SSH, and it's running that Ansible Playbook. As you can see, it's running it again with that extra vars that we specified and the version which is coming from our PACA configuration file. So that again will just take a couple of minutes. It's just got to go through and install Python and the various other different bits and pieces of software. And then PACA is going to stop that droplet, take a snapshot, and then clean up after itself. And that's it complete. So I speeded that up a little bit, but it doesn't take very long. It's only a couple of minutes. So PACA is completely cleaned up after itself. If I refresh my window here again, it's all, you're not going to see the temporary droplet that was created. PACA has already cleaned all of that up for me. What I will see though, if I go over into my images inside of DigitalOcean, is that image that I've just created. So I can see there I've just created 2 minutes ago, and I've got the name example Ubuntu 1664, which is exactly what I want. So now how do I use this? So what I can do is let's have a look at a very simple Terraform configuration. So I have a data element inside of Terraform, and this allows me to query the images inside of my account. So I'm going to find an image with the name example Ubuntu 1604x64, and then I'm using interpolation to get the variable, which I've set to 1. So that should give me the reference to this image here. And I'm just going to deploy that behind a load balancer. So I would run a Terraform plan from the correct folder. Going to add 3 resources, Terraform apply, and then that's going to run through, and it's going to create me a load balancer and my droplets. So the droplets are coming up. You can see that I'm using the image that I've just created, so I'm not provisioning any software on there. This is giving me a consistent approach. I could run this 1,000 times and I'm going to get the same setup. I'm always going to have the same base software because I'm always using this image, and I'm always going to have the same infrastructure because I'm using my Terraform configuration. So one of those is created, just waiting on the load balancer, and that's almost done. And there we go, that's created there. So if I just grab the IP address of my load balancer and open up a new tab in my browser. As I said, super simple. All I was doing was just adding an HTML file. But that's it. I mean, that's really, really simple. It's how we can set things up. If I had a lot more complicated application, then by using PACA also to pre-build my images, pre-baking everything and then just using them, it's going to make my Terraform configuration a lot quicker. And also, I guess, just back on that thing, consistency and reproducibility. So that's it for this session. So what we're going to do next time is we're going to look at how this kind of all ties together. So I'm going to show you some ways that you can use your images and how you can do things like rolling upgrades with Terraform on DigitalOcean. So thanks for watching. The example project you can find there at the GitHub repo. And if you want to ping me, I'm in the Hatch Slack, but also you can get me on Twitter or by email. Thanks again, and I'll see you next time.